8.1b is a review again of the Pythagorean theorem. We're talking about this again because the Pythagorean theorem is very important in geometry. There are right triangles everywhere, and so we need to know how to solve for the various sides of a right triangle. So for every right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the legs. So if you remember about a right triangle, our hypotenuse is our long side of the triangle right here. And then our legs of the triangle are our two sides that make up the right angle. So our hypotenuse is always straight across from the right angle. That's an easy way to find the hypotenuse. And our hypotenuse is always going to be c. So our Pythagorean theorem formula is c squared equals a squared plus b squared. If you don't have that memorized yet, you should get that memorized because it's going to come in to use a lot. We use the Pythagorean theorem only with right triangles, so we must know for a fact that there is a 90-degree angle in that triangle. And the reason we want to use it is anytime we are given two sides of a right triangle, we can use the Pythagorean theorem to find our missing side. Let's look at a few examples. So the first one, it's asking us to find each missing length, which here we have b. That's our unknown. So the first step I'm going to do is I'm going to write my Pythagorean theorem to this side. I know that a squared plus b squared equals c squared. Then I'm going to label my sides. So c squared is the important one. This is our hypotenuse. So my longest side straight across from my right angle is c, right here. And then my legs are the two other sides. So I already have this one labeled as b, so this one is going to be a. Now I can plug in my numbers. So I know that a is 12, so I'm going to have 12 squared plus b squared equals c is 15. So this is my equation, and I'm trying to get b by itself, so I'm going to subtract 12 from both, or 12 squared from both sides. I have b squared left on this side, and when I do 15 squared minus 12 squared, I get 81. My final step is to get rid of the squared, so the opposite of square is square root. And I get b equals 9. So we're going to do a similar thing over here for number 2. Number 2, though, our angle straight across from my right angle, our side straight across from the right angle, c is our unknown. We know our legs, a and b, are 3 and 6, so when we plug those in to a squared plus b squared equals c squared, we get a is 3 squared, b is 6 squared, and c is our unknown. 3 squared plus 6 squared gives us 9 plus 36 equals c squared, and that is 45 equals c squared. Take the square root of both sides. 45 is not a perfect square, and so to find the square root of 45, I'm going to break it up. 45 can be broken into 5 and 9. 5 times 9 is 45. I can break up 9 farther. I have 9 is equal to 3 times 3. So I have 5, 3, and 3. So my c is equal to the square root of 5 times 3 times 3. I can pull that pair of 3's out, so I have 1 3 on the outside and 5 left on the inside. So that is my answer for C. Our Pythagorean theorem can also be used to prove whether or not a triangle is a right triangle. So our next examples are asking us to prove whether or not it is a right triangle. The first step in this problem is to figure out which side is the longest. So if we have 24, square root of 24, 7, and 9. First thing I want to know is which side is my longest. So first I'm going to type in square root of 24 in my calculator to see what that is. And I get 4.9 about. So I know that since square root of 24 is about 4.9, 9 is my largest side. So that is going to be my C. So when I put these into my Pythagorean theorem, a squared plus b squared equals c squared, I know my c is going to be 9. So I have 9 squared on this side, and then my a and b are going to be my other ones. And so when I plug a in, I need to make sure I'm plugging in my original number, square root of 24. Because if I put in 4.9, that 4.9 is a rounded decimal, so it's not going to be exact. We have to put in the exact number that we have for a. So that would be square root of 24 squared plus 7 squared. When we take this square root of 24 squared, that leaves us with 24. Because the square root and squared are opposite operations. They cancel each other out. So we have 24 plus 49 equals 81. On this side we get 73, and this side is 81, so those are not equal. So we can conclude that these are not right triangles. Let's look at number 4. Number 4 is easier. To start off, we know that right away that 10 is our largest side, so that's going to be C. So if we have a squared plus b squared equals c squared, we can plug in 6 and 8 for our a and b, and 10 for our c. 6 squared is 36, and 8 squared is 64. 64. And 10 squared is 100. I know that 36 plus 64 is 100, so I get 100 equals 100. So that says yes, these are right triangles. Okay, we got another example down here next. This question says a rectangle is 8 meters long and 3 meters wide. Find the length of its diagonal. So let's draw in its diagonal. And if we know it's a rectangle, we know that a rectangle, all 4 corners are 90 degrees. So that gives us a right triangle right here. If we want to find the length of its diagonal, that is our C. It's straight across from our right angle. So we need to use our Pythagorean theorem. And we have our legs of our triangle A and B. So A is 3 squared plus 8 squared equals C squared. 3 squared is 9. 8 squared is 64. 9 plus 64 gives me 73. And to solve for C, I need to take the square root of both sides. Now, the square root of 73, I can't divide 73 by any other numbers besides 73 and itself. So that's its simplest form under the square root. I can't divide that 73 into anything else. So I either get square root of 73 equals C, or if I want to type that square root of 73 in my calculator, I get about 8.5 meters. Either answer is acceptable. Okay, we have one more question. How far up a building wall will a 12-foot ladder reach if the ladder's base is 4 feet from the building? Okay, so how far up a building wall will a 12-foot ladder reach? So if we have a building in the ground, we put up a ladder that is going from the ground to the building wall. Our ladder is 12 feet long. We want to know how far up that wall will the ladder reach if the base here, the bottom, is 4 feet from the building. So we're trying to find this, our x. Now, if we have a building, we're going to assume that no one built that building at a slant. They built it straight up and down. So if that building's straight up and down, we would have a 90-degree angle right here. Straight across from that 90-degree angle is our hypotenuse, which is our ladder. So our 12 feet is going to be our C. That makes our legs, A and B, here. So we have A squared plus B squared equals C squared. My A is 4. My B is X, that's our unknown. And my C is 12. Now I can solve, subtract 4 squared from both sides. Get X squared equals, X squared equals 128. Take the square root of both sides. My square and square root cancel on this side, so I'm left with X and the square root of 128. We can split our 128 up. We would get 2 times 64. Split 64 up, we would get 2 times 32. Keep splitting 32 up, we would get 2 times 16. 16 is 4 times 4. And I'm going to stop right there because I know I'm going to have a pair of 4s. So I've got 2 4s and 3 2s. Square root of 2 4s, 4 times 4, and 3 2s. Now I can take out my pairs. I have a pair of 4s and a pair of 2s. I'm left with 4 times 2 on the outside, square root of 2 on the inside. 4 times 2 is 8, and I still have square root of 2. And if you type this into your calculator, square root of 128, you would also get 11.3 feet.